1, 2, 3. Okay, so I should have said 1, 2, 3, but it's the force of habit. So from now on I will talk in English. Okay, so I'm closing YouTube, so there will not be feedback. And we are now doing an invention called how Israel can kill Fordow in Iran. And this is like so that you will know what the invention is about. And the like official name, so-called official name is MacGyver, bunker, Tesla earthquake machine, chicken killer. Okay, so I will explain everything, but basically it does what it says. How Israel can destroy and kill everybody that is inside the facility that is under the mountain, deep underground and under a mountain of granite, and they are making atomic bombs there. At least they are enriching the uranium there. Okay, so the Iranians to kill Israel. So I will try to make it short, because the Iranians are shooting. Even today they hurt people in my town, in my city, Haifa, and they are shooting us every day. So I hope this invention will put an end at least to the nuclear bomb part of the Iranian destruction of Israel hobby. Okay, so and they will find another hobby like checkmate or something, like chess. Okay, so I will write down I don't have a whiteboard here. Okay, I'm in my parents' house, so it's like I'm doing everything. It's also like 40 minutes past midnight, so I'm a little tired and it's not ideal in any way, but I will do what I can in this improvised environment. And so first of all, I will write the name of the invention. Okay, so how Israel can kill Fordow. I don't know if I pronounce right the name of the place. I thought it was Fordow, but it seems like it's Fordow. It doesn't matter the name. What's in a name? Iran. Okay, MacGyver. Bunker. Tesla earthquake machine. Chicken killer. Okay, so I'm showing you the name. Okay, how Israel can kill Fordow in Iran. MacGyver, bunker, Tesla earthquake machine, chicken killer. Okay, So what are we talking about? First of all, if you don't know at all what Fordow is, I will show you. Here, you can see in Wikipedia, you can write Fordow fuel enrichment plant. It's not really fuel, it's more like making bombs, but Wikipedia. Okay, so this building, okay, underground bunker, is under a mountain of granite, okay, like 90 meters of granite, okay, so it's like really deep. And if you look in Wikipedia also, in bombs that like bunker busters, that the bombs that USA can give us, it seems that even with the bunker buster, it's not enough. Look, in Wikipedia, GBU 57A/B MOP, I don't know what MOP means, massive ordnance penetrator, okay, this is like the bunker buster. So they say these components collectively enable the bomb to penetrate 61 meters, okay, so this is less than what we need. We need 90 meters, so this is still not enough, okay, of reinforced concrete or soil. And here we have both concrete, the bunker itself, I don't know how thick, and I will show you that my invention go past this hurdle, so we don't care how thick it is. In fact, the thicker it is, the more they die, okay? And or soil, but here it's like even more than soil, it's granite. And I take advantage of the fact that it's granite, okay? So for example, they cannot use it against us, against Israel, because in Dimona, where Israel has a nuclear facility, we have sand, okay? It's like it's in the desert. If you ever go there, and it's like covered in sand, which is soft, and granite is hard, so it's totally different in seismic waves propagation, and this is critical for the invention, okay? So my whole invention is based on the fact that the whole facility is built from hard materials, like the granite on top, below this the bunker, which is concrete and maybe steel, and hard things, okay? So what we are starting with is first of all, why the name MacGyver? This is more like the fun part, it's not the serious part, but MacGyver means like improvised, and this is indeed improvised. It's not something, I'm not like a part of the IDF or something, I'm just helping my country, helping the IDF if they choose to use this. It's like in the beginning of Mission Impossible. So MacGyver means the pilot episode. In the pilot episode, they have an underground laboratory, and there is a mysterious explosion. I will not ruin this for you, but it's the best episode in all the series of the original series of MacGyver, okay? So I watched them all. I'm a big fan of MacGyver, the original MacGyver, and it's the best episode in all of them. So you should really watch it. I will not ruin it for you, but this is why I'm talking about this, because in that episode they also have the consequences of what happens when there is an explosion in a facility like this, which means also a leakage of chemicals and fires and the oxygen and stuff that add on top of the situation, which will also happen in my invention, but it's not necessary for my invention. It's just like a bonus. Okay. So the next part, bunker, means bunker, the Fordow bunker. Tesla earthquake machine. Okay, Tesla earthquake machine. This is a famous invention of Nikola Tesla, which I'm a great fan of Nikola Tesla. I think everybody should be. And it's called Tesla's oscillator. Okay, the popular name is Tesla's earthquake machine. It's like you see, it works on steam power. My invention is not working on steam power, not on electricity, but I'm taking the idea of how you can cause an artificial earthquake, okay, by using oscillations. Okay, this is the part that I'm taking. I'm not talking about something that is working on steam or electricity, no. But my invention works on bombs, not like huge bombs, not the bombs that we need to get from USA, like normal bombs, small bombs. Okay, not even nuclear bombs, even though if we do this with nuclear bombs, of course it's a little easier, but we don't need nuclear bombs. Okay, for my invention. So if you want to see deeply like an analysis of the invention, you can, not my invention, of the Tesla's oscillator, of the Nikola Tesla earthquake machine, you can see in Mythbusters, okay? You have this in YouTube, you see, season 4, episode 20, full episode, you can watch it, it's free. To be honest, I didn't watch the whole episode. I know it's like they said it's busted, but from my experience, Mythbusters many times like change one parameter and then the whole thing doesn't work, like the episode of rods from the sky. They totally ruined the idea. So I'm not like disheartened by the fact that it didn't work for them. And also they tried it on a bridge, which is like totally not our situation. A bridge behaves very, very differently than a rigid structure that is like suffering an earthquake in the ground. So a bridge basically moves freely, and it's built from a bridge is like the easiest structure for an engineer to protect against the earthquake. Okay, it's like minimal, but a concrete structure on underground has a lot of I don't know how the word in English is. Like it's forced to it has many constraints. The word is constraints. So it cannot things that the bridge can protect itself from, the bunker cannot. Okay, so I'm not worried about the fact that it didn't work for them, because they tested it on a totally different environment. Okay, so I'm trusting Tesla, which is more serious than the guys in Mythbusters, even though they are nice also. So there's no comparison. He's like the one of the most genius people that walked on Earth. So I'm trusting Tesla. Okay. And the idea is very, very basic. So what's the idea? The idea is like resonance. Okay, so the basic idea is resonance. I'm sure you know what resonance is, but still I want us all to begin like on some common ground and work from there. So I'm not assuming anything. I will explain each new term. So resonance, okay? Resonance means like you have a child on a swing, okay, like like they have in a park or something, where children play, and you push your child on the swing and he gets back to you. Okay, so like you have this is the ceiling, and this is you have a rope, and the rope here is connected to a seat, and the child can sit here, okay, and this he or she are holding onto the seat. The seat is like that, and you push them, okay, you stand here and you give them a push, and you know the swing goes like a pendulum, front and back, and swings. Okay, I'm sure all of us did this when we were children. I was never really good at it, but the theory is very simple. You push, you don't need any force. Of course you need a little force, but you don't need a lot of force. You just need good timing. Okay, so the idea of this push is the timing. Okay, so timing is everything, and especially in resonance. Why? Because you need the right frequency. Okay, so what does it mean, frequency? Once every how much time am I pushing the child? If the rope is longer, then the frequency will be longer until he comes back. He or she, let's say it's a girl. So until she comes back. So I need to push each time when she's going in that in the right direction. Sorry, if I use my force and she's coming towards me, then it's not good. If I'm timing just right the small push that I'm giving her, then she will go each time higher and higher until it's really dangerous. Okay, so basically, and then the parent should stop, but here we don't want to stop, here we want it to be dangerous. Okay, so what? Of course we are not playing like children with the Iranians, so they are trying to kill us. So what are we doing? Okay, so we have, I'm sure you all know this, an opera singer, someone with a strong voice can take a glass. Okay, this is not a good example, but this is what I have. Can take a wine glass and break it with her voice. Okay, I'm sure you know this. I will show you I cannot show you really a movie, I'm just because it will be against intellectual property rights, but I will show you a link here, shattering a wine glass with sound at 187,500 frames per second, the slow-mo guides. Okay, so you can check it out. And here, if I did play this video for you, you would see that if this is the wine glass, I know this is not a wine glass, but let's assume, then these plastic glasses simulate the wine glass for us, so I will show you what happens in slow motion. This is what you see if you watch the movie. The wine glass goes this way and comes back, and then this way and comes back. Each time it squishes in a opposite direction. Once it's from the sides, okay, and the next time it's from the top and bottoms, okay, sides and then bottom and top, sides and then bottom and top. But imagine this like hundreds of times in a second. Okay, how many times a second? Here, if you have glass eardrums that resonate at 505 hertz. Hertz means how many times per second. So 500 hertz or 505 means 505 times per second. Okay, so like it's really fast, but if I do this, it's like you would see the wine glass in slow motion. You see this, it's very impressive. And then if you do this for a short time, like then the wine glass breaks apart, like it shatters. Okay, and a wine glass is very delicate, but the same thing happens to buildings in an earthquake. Okay, very strong buildings, if the earthquake hits them in the correct, in the precise resonance frequency, then they fall and crash down. Okay, so the opera singer, many people think that the important thing is that she's singing very loudly, but the more important thing is that she's singing in the correct pitch. If the voice is higher or lower, even if she sings very loudly, it will not help. She needs to sing in the correct pitch. So excuse me, I will go to the bathroom for a moment and then I will come back. So forgive me, I'll just check that you can hear me. 1, 2, okay. Sorry. So we are continuing from where we stopped. Okay, we talked about the glass, how it shatters, and in the same way a building shatters. Okay, in an earthquake, I will show you. There are different kind of waves. Okay, we talked about this in other inventions of mine, so I will not go to this into this like deeply, but let's see this in the surface waves are the ones that are causing the most damage, and basically we are trying to create surface waves. Okay, we'll explain how. Okay, in a moment. Seismic waves. Okay, so we have 2 types, like 3 types, but 2 types of surface waves. Here, surface waves Rayleigh and love. Okay, and there are also other waves which I'm not going to talk about. Here, you can see here the 2 types that I'm talking about. Thank you to Luke Triton, Stephen Earl and Mario Bacik, and Lovorka Librick, Dangela Juric. How many people did this drawing, illustration? Dangela Juric, Kakunik, Meho Sasa, Kovacevic, modified after Bacik, Mario et al. And others. Okay, the useful of seismic surveys for blah blah blah. You can read it here. Okay, so here you have a P wave. Okay, this is what is coming from below, if I'm not mistaken, but for sure these are, yes, like body waves. And Rayleigh wave and love wave, waves in plural, are the kinds of waves that cause the damage. Okay, so basically what we will create is Rayleigh wave. Okay, and I'll explain how we will create them in a moment. But these are the most destructive waves. The surface waves are the most destructive waves. Okay, the ones that cause the bunker to fall, to crash. It will not fall, but it will collapse on itself. It will implode. The opposite of explode is implode inwards. Okay, so the people inside will die. Okay, and more importantly, the equipment inside will die too. Okay, or be buried in a way that is very like destructive for the equipment and the scientists, all the personnel inside the bunker. Okay, so I'm closing this. So here we talked about everything, I think. I will minimize this window and we'll see if I have more windows. Okay, this I will get to later. Here you can see it's an article in Haaretz. You can see picture, okay, from above. This is in 2009. Here you can see in Ynet also a picture from above. I think this is more recent. One moment. It's not really relevant to the invention. I'm just trying to illustrate for you how it looks like. Okay, so you can see pictures here if you want. Okay, so This is the same picture that we saw from 2009. Anyway, this is now like much deeper and so on. Okay, so let's continue to explain through the name of the invention, and then we will like fatten it up, put more details on the skeleton. Okay, so we talked about the Tesla earthquake machine. Now we'll talk about the chicken killer. Okay, what does the chicken killer mean? Chicken is not like insulting the Iranians. It's not like that, even though they are cowards that they kill civilian population here, while we are only attacking their military facilities. Personally, I'm against this asymmetry. I'm for like killing their elite civilian like Khamenei and people that support him that are civilians. So we will encourage a revolution there that will be like supportive of Israel, people that want peace, not killing, but never mind. So we are leaving the geopolitics behind us. We are talking now again about like mechanics, physics, stuff like that. Now it's about biology. Chicken, if you will see in like literally chicken that you can, you know, the bird that lay eggs, and we also eat the bird. And if you see here in zoology, I'm sorry, this is from the website Skeptics, stockexchange.com. skeptics.stockexchange.com. Questions, blah blah blah. Can a 7 Hz tone kill chickens via resonance? Okay, this is the question that they are asking. Can a 7 Hz tone, the sound of 7 Hz, remember here there was like 500 Hz, so a much lower pitch sound, like even below bass sound. Can this sound alone, if you put this sound in a loudspeaker, or if you can sing it, you cannot, but if you can put it on a loudspeaker, can this kill chickens, the birds, chickens, via resonance? Okay, can this make to the skull of the chicken the same, once like this, once like this, until you kill the chicken? Because the skull, the head of the bird, will behave like the glass. Okay, so I know this is plastic, but imagine this is a wine glass made out of glass. Okay, so this is the chicken killer. So now I will read to you what it means. Of course, we are not trying to kill birds. We are trying to kill Iranian military scientists. Okay, so let me read it for you. Not everything, but like a little bit. In the sound function, this was asked 7 years ago by I don't know how to pronounce it, by Dong NTBK, DUONG NTBK, and it was edited by this person, WRZLPRMFT, and the answer came from, I will show you the rest of the answer, which means probably yes. This answer came from Schwern, SCHWERN. Okay, so we will read this like more or less. You can read all the details if you go into the link that I'm showing you. Okay, so the question goes like this. In the sound function, okay, section of the Turbo C, this is like an old programming tool from the old days, like, I don't know, 40 years ago, that I used also 40 years ago, not 40, but like 30 something years ago. Turbo C version 2 reference guide from 1988. I was 10 years old. I found the following comment. Emits a 7 Hz tone for 10 seconds. True story. 7 Hz is the resonant frequency of a chicken's skull cavity. Okay, the space, the empty, not empty, there is a brain inside, but the space inside the skull of the chicken, of the bird. This was determined empirically in Australia, where a new factory generating 7 Hz tones was located too close to a chicken ranch. When the factory started up, all the chickens died. Okay, so we want to kill all the Iranians inside the bunker, so it's very, very similar. Of course, we transmit the vibration, the sound, not directly. It's not through air. I'm talking to you, and there is air here, and like here to the microphone. And I'm speaking, and the airwaves carry the sound. But there we are, what carries the sound is the ground, the rock and the concrete. And from there, it translates back to another phase, which is the phase of air inside the bunker. Okay, so we have like a middleman in the middle, but the process is very similar. We are making a sound, it goes through the rock, the air and stuff, and goes to the Iranians inside and kill them. Of course, it's not 7 Hz, it's the sound, it's the frequency that we will talk about in a few moments. Your PC may not be able to emit 7 Hz tone. Okay, so this is a true story. And here someone says it's not a probably not a true story, but anyway, he analyzes whether it can be a true story, and the conclusion is that yes, and in particular, as for killing a person, you would have to use 240 decibels source to get the head to resonate destructively, the head of a person, of an Iranian military personnel or scientist. At that point, it would be faster to just hit the person over the head. Of course, this is not available for us, because if we could shoot them, we would shoot them, but they are hiding inside the bunker. So for us, it's easier to make this. So the question is, oh, and of course, like the resonance, which is interesting, if you sit in front of a very good quality subwoofer and play a 19 Hertz sound, okay, it's like 3 times more almost than the 7 Hertz of the chickens. A person needs 19 Hertz, almost 20 Hertz, or have access to sound program. Your eyes will twitch and you turn up the volume, so you start approaching 100 dB, like more volume, more power. You might even start seeing colored lights at the periphery of your vision or ghostly gray regions, blah blah blah. Okay, so it's like very destructive for the person. Okay, of course, if you okay, so another thing, the tissues, the soft tissues inside your brain and inside your skull, the brain for example, they are acting as a dampener, okay, like they are damping, they are making the vibrations lower. But if you make big vibrations, like strong vibrations in the correct pitch, in the correct resonance, and the correct frequency, then the soft tissues can protect them only up to a certain point. From that point onwards, if it's strong enough, the vibrations, it will kill them anyway. Okay, so this is the part about the chicken killer. So you see, it's not like an insult, it's like physically kill them like chickens through the sound, through the vibrations, through the correct frequency. Okay, so we see that we want to do two things, like even three things to the I'm just stopping like intermediate summary. We see that we want to kill the Iranians Fordow plant in three ways. One, all of them through vibrations. So one is the physical collapse, the implosion through earthquake. This is a certain frequency. Another frequency is the vibration that make them first suffer and then die from the vibrations in the ground. They are locked inside the vibrating, it's like being in an echo chamber, but not metaphorically, but physically. Okay, so it's like a guitar has a resonance chamber. So imagine you're inside, but much louder and in the frequency that we make it the correct frequency for you to die. Okay, and of course another way to die is all the damage that, like in the episode of the pilot of the series MacGyver, where all the fires inside and the poisonous materials like uranium gas and radon gas and fluorine. Fluorine is very reactive, so it's like chlorine, like it's corrosive. It's like it kills you on even if it touches you. And uranium gives you lung cancer, and it's very unpleasant to oh, and also it combusts. Okay, so micro uranium particles, they are metal, and if they are exposed to the oxygen in the air, they combust, they burn. So you have fires. So you have less oxygen there, you have fumes, you have toxic gases, smoke, particles, and like they will die inside in a very unpleasant way. Okay, this is from the shaking and from the, this is not like the chicken farm, this is like the earthquake. Okay, so now how do we do this? Like, okay, it's very nice. we so far it looks like we imagined that we are making an earthquake without explaining how we actually do this. Like we assumed, okay, if we would make these vibrations, then we would have so and so impact, so such and such effect. But how do we actually cause this effect? Okay, so this is what we will talk about now. Okay, so this talked about This we talked about. Okay. So now we are talking like more the technical part of the of this invention, and it all the first part is make the actual shaking will be in a very specific way by bombs, very specific way. It's not just throwing bombs, it's much more complicated. But the first of all, to know the frequency, the correct frequency that we need to shake the structure, like once in every how much time do we need to push the child in the swing, like is it once every 2 seconds, is it once every 2.5 seconds, 3 seconds, like how much do we need to wait, what frequency do we need. So what is the natural internal frequency of the bunker? This needs to be measured like physically. It's not something that we can guess. Okay, the Iranians will not measure it for us. Okay, so first of all, the first step is to use two devices. I will explain exactly how to use them, which are accelerometer. This measures how much acceleration, how much like speed is the stuff is moving. And we have something called triaxial seismic accelerometer set. Okay, this is costing something like $3,000. Okay, about. Okay, I will open this in a new browser window for you. Here we have it already. KS48C3 plus 729 tripod floor plate set. Okay, this is how it looks like, and this is the price. Okay, so I'm not trying to sell this to you. I'm just saying this is from Roga Instruments. I'm just saying this is more or less what we need. Okay, it measures in all 3 directions, and we need to attach it to the ground. How do we attach something like this to the ground? We attach it with a epoxy, okay, with glue, like normal glue. It's more like super glue, but you can buy it in any store. Okay, epoxy. You can see in Wikipedia. It works also on concrete. It works also on rock. It works on electrical things, so it works also on metals. So you can see that it will take a few minutes, and it will glue very strongly this part to the ground, like to a rock or whatever it comes into contact with, and we make a device. Let's draw this like schematically. Okay, let's assume that we have the part that the sensor. Okay, and the sensor is made of 2 parts. I will write down their names. Accelerometer, plus what we also need is something to analyze what the accelerometer output. Okay, so it gives us some frequency, some wave, and we need to take this wave and make a digital number from it. So frequency analyzer. I will show you this also. Okay, so we need accelerometer, which I showed you, and we need frequency analyzer. I will show you this now. And they are together, they are the sensor. Okay, I will explain. Okay, so the frequency analyzer that I chose is like from the picture in Wikipedia. Of course, maybe you can find a better one, not this one because it looks sensitive. I want something more robust, which is handheld spectrum analyzer. This picture is thanks to a US Air Force image by Tech Sergeant David Salantiri. Okay, and thank you to United States Air Force, blah, 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 blah. And here we can buy this. So this is called N9340B. Okay, it's called handheld spectrum analyzer. Yes, analyzer. It's hard for me to see what's written. Analyzer, and you can buy it for here. No. Well, I found somewhere that they sell it for $5,300. Okay, $300. So this is like about $3,000 and sorry, $3,000, and this is like $5,000, and together it's about $8,000. Okay, so about, more or less. So of course, in terms of a country like Israel, it's nothing. Like this is practically for free. Okay. So how will it look like? And of course the rest of the device needs to come also. So it will be like a projectile that you drop from an airplane. Okay, sensor schematic. You have like something that it either needs to be very robust or like with a small parachute, okay, and like it will stick to the ground or something. And here you will have the glue, okay, epoxy. You will have the accelerometer. And you will have the analyzer. And I don't know how to draw this, but you've seen this is like the accelerometer is like a plate, and it has 3 small tubes. Something like this and like this and like this. And the glue, of course, will come between the ground and here there will be glue. and the glue is binary, so you know how epoxy works. With one type of glue will be spilled on the ground before the impact or right after the impact. Another kind will be here, and this part, this type and this type together, they make the glue, the binary glue work, okay, active. Okay, and then the this thing is attached to firmly to the ground, like after 5 minutes, and it's very fast. It's fast glue, and also in this device will be the sensor, the analyzer, which will analyze what the accelerometer is sensing, and it will broadcast. Okay, it will have some, like antenna, and it will broadcast to us the result. Like it will say to us, okay, listen, the frequency, the internal resonance frequency of this bunker is like so and so, some number. I don't have any idea what the number will be, but so and so hertz. Okay, so we need to make some explosion, which will be like shaking, like finding out the wine glass, the wine glass's internal frequency. Okay, before we start the opera singing, shattering of the glass, we are making like hitting the glass, and we are listening not with our ears but with the frequency analyzer to analyze what number is the frequency. Okay, how many hertz we need to set the voice in order to break the glass. Okay, it's very important. Sometimes you do like an action, like moving your finger on the crystal wine glass, and then it makes a sound. Okay, it's the same. It's like you're making the frequency. It makes like ooh. So it's this sound that will break the glass. If you create this sound, even artificially, you don't have to be an opera singer. If you have some device that makes the sound, of course, we will not need a sound from an opera singer. We will need the shaking from a bomb. Okay, but the correct synchronization of the bombs will be the key to the resonance, to the effects of the resonance. Okay, so I will explain. Okay, so remember we have the sensor. We talked about it. We parachute a very small sensor from the air. This whole package is like the size of a shoebox or something like this. It's very small. In the night, you deploy it to the ground. You don't need commando units. You just need to drop it silently from some drone. Okay, so the drone can just put it close to the floor, and then you don't need also the parachute. You can just put it with the drone, and the drone flies away, or doesn't even need to fly away. It can just wait there. You can sacrifice this whole thing. We just need it. We don't need it back. We just need it to broadcast to us with the antenna, like maybe to an airplane that flies above or something, that will catch the answer. And we need just this number, like, I don't know. I I don't want to give a incorrect answer, but let's say it's like that sound of 19 hertz, okay, to kill the people. So maybe it's like similar. So it will tell us, okay, 19 hertz. Okay, so how will it make it, how will it tell us? Like, what will be the equivalent of making like this, the sound, or like this? Like checking what sound, what frequency is the correct internal frequency to make the whole bunker resonate. Okay, so let's see. Okay, so this question is really easy. The initial I don't know how to call this, like a check, the initial resonance, the initial frequency check. A small bump or charge. Okay, charge is another word for a bump. Okay, so the initial frequency check is done by a small bump. Okay, what do I mean? We glue the sensor. This is like the ear that is listening and the mouth that tells us, and then we need to make the ping to check. Okay, so the check is done by dropping a small bump anywhere close by, and even better if you have the, let's say this is the mountain and this is the bunker. Okay, let's say here there is a door and here is the bunker. So if our sensor, okay, is here, this thing somewhere on the mountain, then maybe the bomb needs to be dropped here. Okay, not close to the sensor, because we don't want to check the bomb itself. We want to check an explosion that is a little far away. Okay, this is the bomb that we drop from an airplane or something, like a shell, a mortar shell or something. So the vibrations will come here like this. It will shake a little bit, very tiny shaking of the bunker. They will probably feel it like really a little bit. It will not damage the bunker, but it will resonate a little bit in some frequencies more than other frequencies, and the frequencies that will propagate the most, these are the frequencies of the internal resonance frequency of the bunker. Okay, it's like, it's automatic. It does this because these are the frequencies that continue. The others are just silenced, lose energy, but the ones that are in the same frequency of the resonance frequency of the bunker, this does all kinds of frequencies, high, low, too high, too low, but the correct ones will continue and will propagate here to the, in all directions, but specifically also to our device, which will broadcast to us, listen, it's 19 Hertz, for example. Okay, in this hypothetical example. Of course, it will not be 19 Hertz, it will be something else, but I just want to have some number to tell you. And our airplane, okay, I don't know how to draw the airplane, but let's say this is the airplane. We'll catch this answer and we'll record this answer, and we will know this number, what is the correct resonance frequency of the bunker. Okay? Okay. So this is like really easy. Okay. Now the less easy part is, again, I'm drawing the bunker. Okay, this was the check. Now we are making the actual earthquake machine. Okay, the earthquake machine is not the same as Tesla's, but it's the same idea. We are using artificial vibrations to make an earthquake, an artificial earthquake. Okay, we are making this not by electricity or steam, we are making this by a few bombs. Okay, like regular bombs dropped from an airplane. We don't need to be on the ground, we don't want to be on the ground, we want to drop them from an airplane or something like this. Drones, whatever. Okay, so it, of course, we need an airplane because they need to be big bombs. Okay, not atomic bombs necessarily, but significant bombs. It cannot be drones. Okay. If you want to do this with drones, theoretically you can, but it's like pushing the child only with your little finger, so it will take you like a whole year, and you need to be very accurate. Okay, so it's like very, very complicated. We don't want to do this. We want to make to use the biggest bombs that we have for this. Okay, so let's say we have an earthquake machine. Again, we have the mountain. Again, we have the bunker. This is the door. This is the tunnel. This is the bunker. Good. Now we want to make to drop bombs. We cannot drop the bombs on the bunker itself because it's under the mountain. So we are dropping the bombs on this side, okay, on the mountain, on the granite. This all is still granite, and this here it's also granite. Even if it's mountains here, it's all hard rock, condensed rock, which is important because it will transfer all the vibrations like ideally. Okay, so, and the concrete of the bunker itself will also transfer the vibrations, which is also important. Okay, so this is all tailored for Fordow. Okay, it will not work in other places. Okay, so let's say we are putting a bomb here and here. Okay, this is a bomb, and this is a bomb. Okay, so remember this drawing. Now I will draw this from above, like if I'm looking from here downwards. Okay, you are starting to understand that this will press it like this, but now I want to show you how to press it like this also. This is from the sides. Okay, this will make basically in the correct, I will explain why it will be in the correct frequency, but this will make basically vibrations in all directions, but the vibrations that we care about that will be effective will be those that will reach from here and from here. And the timing is very important. Okay, timing is king in all this invention. Timing is everything. Okay, timing. The timing will be set in a wireless communication between the bombs. Okay, when are they triggered exactly? And it will be split second, like, important. Okay, it will be, it's very sensitive to the timing. The timing is really important. The more accurate you make the timing, the less bombs you need, the less powerful bombs you need. The timing is very, very important. Okay, so they are electronically triggering each other, and this knows how far it is, this knows how far it is, and they detonate themselves, so this reach like the child on the swing, like this pushes to here, the bunker is pushed a little to here, and then this, when it returns, only then this bump pushes from here. So we have a few bumps back and forth, but it's really crucial and critical when the timing will be. The precise timing is very important. Okay, so now we will watch from here, from above. Okay, so this is an earthquake machine from the side, from sideways. And in the next slide, we will watch the earthquake machine from above, from here. So we will see these bumps, and we will see also a bump here and a bump here. Okay, like from the front and from the back. This will be like these pushings from the sides, and the front and back will be like the top and bottom of the glass. Okay, earthquake machine. From above. So we have the mountain, but now it's like round or something, like this is the mountain. Let's say here is the door. We cannot see the bunker, but it's like down here from above. Also from the side we couldn't see it, but here we definitely cannot see it. It's here. But the bombs will be the ones that we saw before are here. They don't need to be symmetrical relative to the bunker, but they need to compensate. If this is further away, it needs to trigger beforehand. Okay, so they need to compensate. They know by GPS or by other method. It doesn't have to be GPS, but we need the bumps to know where they are and what is the distance, and then they broadcast the triggering signal so that they will push in a precisely the correct timing. Okay, and other bumps will be like from the like sideways versus top and down. So this is the top and down, which was front and back. when I explain to you. So this is like another axis. This is one axis, and this is a perpendicular axis. Okay, like we have this axis and we have this axis. Sorry, I hope you understand. So we need to squish the bunker like so, and then like so, and then two other bumps like so, and like so, and a few times like this, until the bunker gives way, until the bunker collapses on itself inside the mountain, below the mountain, whatever. Okay, so this is the whole idea. Okay, so let me see if I missed something, if I missed anything. This we talked about. This I've shown you. This is like more hardened equipment, so it can be deployed in the field. This I explained to you. I mean, the mechanics of the Rayleigh wave, I'm sure if you bring a geologist, he can explain it better, but basically it will move along the ground. I just want to explain what I mean by, like, we split the vector into two vectors. Okay, I will just explain this. Vector. Okay, vector, if you don't know what vector is like arrow, like an arrow pointing into this direction, or an arrow pointing into this direction. Okay, so if we have the ground, okay, this is the ground. Okay, this is above ground, this is below ground. Okay, let's say here is the sun. So, and let's say we have a bomb here. Okay, we are making an explosion here, bomb. Okay, so, and let's say the bunker is about here. Okay, bunker. So the vector that we need, that is going in the direction of the bunker, is this direction. Okay, this is the vector. But this vector, I mean this bomb, also gives a vector downwards. Okay, let's say it like this. This vector has two components. One is vertical component, like so, and one is horizontal component, like so. And what will shake the bunker the most is the horizontal component, because against the vertical component, they hardened the bunker. They thought about it. They are enforcing, they are hardening the bunker against bombs from here. But they didn't harden the bunkers against forces from the side. So when this bomb, I drew it like in the wrong way. It's like far away, and it has a component from here. Okay, so let me draw this again. Okay, this is vector zoomed. Okay, this is the bunker zoomed. Okay, and it shakes the bunker. Let's treat the bunker like it's one point in the middle. Okay, so from this point, the whole bunker, is like 1 point, let's say, for simplicity. So this point is, let's say the bomb is from here and it's moving in diagonal direction like so. Okay, this is the vector. This is the vector. So this vector has two components. Okay, if we make like a drawing of the components of the vector, this is the vertical component and this is the horizontal component. And the horizontal okay, this is the vertical component of this vector. This is the part that goes up and down. In this example, it's down because the bomb went up here in this direction, like here, bomb. And this is the vertical component downwards. And this is the horizontal component to the right ways. Okay, so towards the right. So the thing that kills the bunker is the horizontal part. This is what you see on the screen, the Rayleigh wave. Okay, this is equivalent to the Rayleigh wave. It's not a natural Rayleigh wave, but it's an artificial Rayleigh wave, and it behaves just the same. Okay, so it pushes the particles of the granite or the ground and shakes the bunker towards that way, like pushing the swing of the child there. And then it comes back either by itself or better yet by another bomb. We will do it by another bomb, that way it's more effective. And we do once from here, another from here, once from here, another from here. Imagine the child has both a father and a mother, and each of them pushes in a different direction. Once the father pushes, then the mother pushes back, then the father pushes, so they need less work. They split the work. Okay, it will be faster. Okay, so basically this is it. I think we went over all the parts of the invention. Of course, I could do it like more, serious, but with deeper research, more insights, more to refine the idea further. I'm sorry, but every day is critical because, like, the Americans can stop us, Israel. They can, like, say stop this operation, and I don't know, like, we are in a war, we are not in a game. So every day is critical. Okay, so I really hope that, I'm sure that this will work. I just want, like, the experts to take it and, like, make it real in the sense of, the final touches or the refinements. But the basic idea I'm positive about. Okay, so This I talked about. This I talked about. Again, it's not the same frequency that kills like the chickens. That it's not the same frequency that makes this earthquake that collapse the bunker. It's not the same. You can do this, you can do this, you can do both. Okay? You do this, you do both of them in the same way. You do them with bombs. Okay? But it's not the same set of bombs. Okay? What else? This we talked about. Again, uranium is poisonous. Lots of damage to the body. You can see here in Wikipedia effects and precautions. Again, we talked about the fluoride and so on. Fluorine, which is present many times in these facilities because of how you enrich uranium. The uranium itself, which ignites when it touches the oxygen in the air inside the bunker. Lots of fires. They will die in an unpleasant way. The same way that they arranged for us in October 7th. Okay, so and the way that they planned for us to die in an atomic bomb. It will be as unpleasant as they planned for us. Okay, so I think we went through all of what I wanted to do now. How much time did it take? Yes, everything. We went through everything. It took us. Where did it say? I think 1 hour and a half. 1.5 hours, 1:33. Okay, so thank you very much. And goodbye. And I hope Israel will win. Thank you. Bye bye.